Yeah, hi, this is Mohammad Sheikh. Now I was going to explain Big Data Analytics and Applications, ICP9. The main objective of the ICP is I need to develop a linear regression model for sample data set. Okay, actually, linear regression is nothing but based on one explanatory variable, the output will be predicted. In the same way, a multi-regression model is nothing but based on the two plus variables or features, the output will be predicted. But for the in this ICP, I was going to implement the simple regression model, simple linear regression model for the data set which I downloaded from the Kaggle. It's a some sample data set. Okay, let me share my screen. Okay, so this is the ICP9. Now I need to develop a linear regression model so that I need to calculate the slope, intercept, and also the best fit line for the model, and then SSC, the sum of square error, or MSC, the mean square error. So let's go into the code. So this is the actual code. Here you can see. So firstly, I will be importing the necessary libraries. So here you can see NumPy. I was importing NumPy as NumPy and Pandas as PD, and then I was importing the visualization library Seaborn as SNS and Matplotlib .pyplot as PIT, and then also I was importing the machine learning libraries sklearn, so where we can build the linear regression model, and also I can calculate MAC, SSC, and so on. So here actually I downloaded the dataset from the Kaggle, so it is in my local a local system. So what I will be doing, I will be mounting the data from a local drive into the Google Colab. So this is the code. You can see where I can upload the data. So when I upload the data here in the Google Colab, here you can see. So this is the data that was uploaded into Google Colab. So right now what I will be doing, I will be reading the data. I will be reading the data from that particular path into a data frame data. So finally, and then I'll be reading the top 5 rows of a data set. So here you can see. So my data set will be having five columns, and then 4,572 rows. So here I had defined like a data dot shape so that I can get the size of the data. So and then the basic information of the data here you can see. So my data, so in my data I will be having the null values also. So here you can see for the TV column, you can actually we will be having the 4,572 column, 4,572 rows, but here it is 4,572. It means that I am having 10 null values here. In the same for the radius also, here you can see nearly 4 null values are there. So in that way, due to the data.info, I can find that my data is having some null values, and I can know the exact information, what the data type and the count, so everything. So what I will be doing, so by this I can drop the null values so that I can so that my model can be work accurately to give the better results. So here what I will be doing, I will dropping the null values, and then finally I'm reading the size of the data. So you can see data size is equal 4546. So whatever the null values I will removing, so every null value will be made from each column, each row, and then the final size is 4,546 rows and then 5 columns. And right now what I will be doing, I will be plotting the data. Here you can see the dependent variables and the independent variable. So actually here the dependent variables is nothing but the sales, and the independent variables are nothing but TV, radio, and social media. So these dependent variables are actually dependent on on the data of TV, radio, and social media. So that's why we can say TV as a independent variable and then sales as a dependent variable. So what I'll be doing, I was plotting the data in XY label. So here you can see. So through this graph, you can find that the TV is linearly correlated to the sales. So it is exactly the linear line. It is in the form of a linear regression model. So whenever the TV advertisements or TV values are increasing, the sales is also increasing. So here you can see it is a completely completely linearly correlated. That means it's a completely linear line. And then when it comes to radio and sales, so here you can see it is also a linear regression model, but not up to the mark. So, as you can see in that, as you can see when compared to the TV and the sales. So social media, so here you can see it's having like some other notation we can say. So next what I will be doing, I will be I'll be doing correlation analysis here. So actually correlation analysis is nothing but it ranges between -1 to +1. So it actually gives the strength and the direction of the variables to predict the actual value. So here you can see what I will be doing. Here I was doing the PHN correlation model. So where here one feature can be known how accurately it is um, how accurately connected to the another feature. So so you can see TV. One feature is one feature how it is related to another feature. I can say simply. So you can see the radio and the TV. So radio is 0.87 correlated to TV. So like that. And then you can say one is the max value I said. So whenever it is one, it is highly correlated in a positive way, and then the low value will be -1. It means that it will be highly correlated in the negative way. So here you can see TV and sales, as we can see in the diagram, as in the graph, it is linearly correlated. It's a linear line. So in the same way, the value is 1. So here you can see TV and sales. TV and sales, TV and sales. So and what the next highest value here you can see is 0.87. 0.87 sales and radio. Sales and radio. So what I will be doing, instead of plotting the graph for the TV and the sales, if I plot the same thing, will be getting the same linear regression model. So it is highly correlated. So I will be perform the linear regression model on these variables, on these radio and then cells. So here you can see. So fine. So my feature will be, so to build a linear regression model, simple linear regression model based on one explanatory model, our output will be predicted, right? So my feature I will be taking it as a radio, and then my target, the output I will be taking it as a sales. So through the data, here you can see this is a 1. So this is a rate 0, 1, 2, 3, 4. This is the sales like that I had taken in the data set. So I was printing the size of the data. So here you can see 4, 5, 4, 6. But actually it is a one-dimensional array. So actually to perform more accurately, or my model need to be give accurate results, it needs to have the two-dimensional data. So that's why what I'll be doing, I'll be converting from one dimension to two dimensionals. And so here you can see this is the code where I had converted. And finally the size, you can see here 4,546 1. So right now, as per the ICP, what I'll be doing, I'll be finding the best fit line and also slope, intercept, and then later on MSC and SSC. So here you can see actually the best fit line formula as per the mathematical, say, algebraic equation, right? So y equal to mx plus b, where here we can say x is an independent variable and y is a dependent variable. So y is a regression line and m is the slope, b is the y-intercept. So let's calculate the slope, intercept, and best fit line. So here you can see this is the mathematical expression. So where we can calculate the slope and intercept. So this is the Python code in the mathematical notations. We can also find in this way, but this is the simple way where we can find the slope and intercept in directly through the function which we had imported from the libraries. So here you can see, to find the intercept, model dot intercept will give the intercept value, and for the slope, model dot coefficient 0, it will give the slope value. You can also find these values by using there is also other way like model.summary. If you directly execute that code, it's a other way. You can find everything like standard deviation, SSC, MSC, everything will be present in the summary instead of calculating each one. So and then next what I'll be doing, I'll be finding the my regression line. So here you can see this is the my regression line, and then I'll be plotting in a graph. It's a straight line. So in the mathematical notation, the linear regression line, the best fit line is sales equal to 8.36 into radio plus 40.58. So next what I'll be doing, I'll be doing the R squared value. So it's a statistical measure where the variance of the dependent is completely explained by the independent variable. So the x will the y will be predicted on the basis of x. So to be said simply. So here through the direct function we had imported through the libraries, I found the R square value. So our R square value is 0.754. And then finally I'll be building the linear regression model here. So this is the function where is a function which is used to split the data for the training and the testing. So so here you can see about splitting the data into training and testing by this function, and also the test size equal to 0. Is nothing but 30% of the data will be going for testing and 70% will be going for training. And then I will be printing the sizes of the data here, each data set here, X-train, X-test, Y10 and Y-test. And then here I am defining the linear regression model. So and then finally I am training the linear regression model for the training data set. Here you can see. And after it is executed, now it's time to predict for the testing data. So here you can see by using this function, I got my predicted value as y predict. So finally I can find MSC or MSC and SSC. Here MSC is nothing but the scale difference between the observation point and the predicted points. So this is the mathematical, this is the actual function. Through the library we can find out mean squared error of y test and y pred. So I got the mean square error is at 2158. So it's quite high, yes, because nearly I had a lot of huge amount of data. So nearly 45,000 records are present in my data set. So that's it's somewhat huge. And in the same way I was calculating SSC. SSC is nothing but the distance between the observation points and then regression line. So so here you can see, as I said, we can calculate by using the mathematical notations or by using the direct function. So here you can see through the mathematical notation, my mean squared value is similar to that of the function. And then finally I will be plotting the regression line for the testing data set here. So here you can see the data set where every point is towards to this regression line. So okay, thank you.